Now, if we consider our temperature entropy diagram, if I have this way, this is temperature. As it increases, the entropy also increases, right? So when the temperature increases from state 1 to state 2, what happened? Temperature will increase. When temperature increases, entropy will also increase, right? So from state 2 to state 3, there's a phase change. That we call saturated temperature. We call it Ts here, right? So the temperature increases, the entropy increases, while the temperature remains constant. Are we good? Now, in between state 3 and state 4, we say we have increase in temperature and also the entropy increases, right? So if I join this together, do you understand? We already said earlier that this is our L plus V, liquid and vapor region. So we'll call it, since it's entropy, we can call it SFG, right? If it's enthalpy, we'll call it HFG. If it's specific volume, we'll call it VFG. That is in between this region here. Are we good? So my SFG is telling me it is a what? SG minus what? SF. My HFG means what? HG minus what? HF. My VFG means VG, specific volume, minus what? That is VG minus what? VF. Are we good? So we know very well that we call this point the liquid region. So I said we use F to represent our liquid region, and we'll call here to be we'll call it our vapor region, and we'll use G to represent our vapor region. Are we good? So we'll call this point here liquid, the wet region, liquid and vapor region. So we'll call it what? My FG region. That is, they exist, they coexist. So whenever you see things like this is what it means. So if we are looking for entropy at a particular state, it will give us what? SF minus SFG, right? Or you see it's saying as saying SF minus SG minus SF. We'll call it SFG. Put our X here. So we'll put our X outside. I'll call it SG minus SF. Are we good? Now we have, if it is for enthalpy, we'll call it maybe HS. Are we good? And that HS will be HF minus SHFG. Or you can say your HX is equals to what? HF minus S into bracket HG minus what? HF. So this is a particular formula on its own. Now what do you notice in this formula here? We are saying this variable here, we call it X, and that X is called our dryness fraction, right? So in our next video we'll be talking about what is called a dryness fraction.